Good morning, everybody. We are waiting just 1 or 2 minutes for people to connect to our European Geothermal Innovation Award 2020.
Hi everyone, this is Sandra speaking from the Exhibition Center Offenburg. I'm very happy and honored that today we announce the winner of the Ruggero Bertani European Geothermal Innovation Award. The award is given to companies which have made an outstanding contribution towards the field of geothermal energy, either an innovative product, scientific research, or projects. Traditionally, it is handed out at GEOTHERM Expo and Congress here in Offenburg. But this year, the event was cancelled due to the COVID-19 pandemic. But this will not prevent us from announcing the winner of the competition by going digital. And I'm sure we will all meet each other in person next year at GEOTHERM 2021. You can already pencil it in your calendar. It will take place at 25th and 26th February. Now, we are proud to present the 5 finalists. Miklos, let me hand over to you for the presentation of the finalists.
Thank you so much, Sandra. Good morning, everyone, and everybody who is listening from all over Europe and all over the world. We welcome you to this ceremony for the Ruggero Bertani Geothermal Innovation Award. In fact, the European Geothermal Innovation Award dates back to 2014, and it has been renamed in 2018 in the memory of the great geothermalist Ruggero Bertani, who has done a lot for the geothermal industry and the innovation and technology. Well, this year's finalists have been selected among 9 contenders, very strong contenders, by a jury which was composed by Adela Menzela from Italy, a research expert, Sandra Kircher from representing Messe Offenburg, Fausto Battini from Italy, representing ETIP, a deep geothermal industry expert, Javier Oshugea from Spain, representing the ETIP of renewable heating and cooling. And myself, I am Miklos Antic. I am the president of EJEC, and I was chairing this committee. Well, the 5 finalists, which were selected among the 9, are in alphabetical order, are Baker Oilfield Industry Supplied for the degasser, which consists in a product of separating gases from geothermal water, Vulcan Energy Resources from Germany, which aims of extracting lithium from geothermal brine with zero carbon process, GE Bayern for their test rig, CarbFix, a process of fixing carbon separated from the processes, and Ever Technologies for their Ever loop. Well, I'm going now to give the word to the first speaker from Baker Oilfield Supply, in order to shortly present his innovation in a couple of minutes. So, Joel, the floor is yours.
Good morning, everybody. Thank you for being the first, and I will give an introduction of my innovation, of our innovation. It's a degasser. It's called the 2.0 version of an existing degasser that can handle lower temperatures and pressures for the basic geothermal industry. This one is also in our rental fleet, and it has been used for a couple of years now. With this new version, we are able to handle the temperatures up to 150 degrees of Celsius and pressures up to 50 bars. There is no need for pumps because the degasser is kept under pressure, unless unlikely like a vacuum degasser. We are able to separate harmful gases and oils from water and steam. After separation, can safely release the steam and water to heat exchangers, turbines, or open air. As far as we know, this type of equipment is not available in the rental market for this range of temperatures and pressures. The product has been used in projects already and has proven its reliability. So we are very pleased to announce it right at this place.
Yeah. Thank you so much, Joel, for this brief presentation of your innovation, which is quite useful in the booming environment of geothermal development in Europe, especially in the Netherlands, where we find lots of non-condensable gases in the geothermal water, and we need to separate them. Now, I would like to pass the word to Eda from CarbFix to present her innovation, which consists in capturing CO2 and other sour gases from emission sources.
Thank you, Miklos. Dear European friends and colleagues, first of all, the CarbFix team is honored to be one of the 5 outstanding projects shortlisted for the 2020 Ruggero Bertani European Geothermal Innovation Award. CarbFix captures CO2 and turns it to stone underground in less than 2 years through proprietary technology. Water with dissolved CO2 is injected into reactive rock formations when natural processes permanently transform the CO2 into stable carbon minerals. In fact, this is Mother Nature's way of storing carbon, but what we did was to find a way to speed up the process using science and innovation. CarbFix started out as a research project in 2006 and has since gone through pilot and testing phases to industrial scale operations and commercialization. An effort led by scientists at Reykjavik Energy, University of Iceland, CNRS in France, and Columbia University. As a result of long-term operations at On Power's Hellisheiði geothermal power plant in Iceland, the CarbFix process has been proven to be an economic and environmentally friendly solution for reducing emissions through mineral storage in underground rock formations. Altogether, the global storage capacity in rocks is larger than emissions from burning all fossil fuel available on Earth. The climate relevance of the CarbFix technology could therefore be significant. It is not limited to the geothermal sector. However, the European geothermal community has taken the lead in developing and exporting the technology beyond Iceland. Preparations for carbon injections at several geothermal sites throughout Europe are already underway. We encourage the global geothermal community to join us on this journey, as our planet is in desperate need of joint and drastic climate action. Stay safe and climate friendly. Thank you from all of us here at CARPEX.
Thank you so much. Now we are going to give the floor to Robert Winslow, who will introduce the Everloop, breakthrough innovation in geothermal production by connecting several horizontal wells with the 2 vertical wells in deep geothermal closed loop system for energy production. Robert, please. I think we can't hear you.
Sorry, I'll start again. Thank you, Miklos. Can you hear me now?
Yes, it's good. Thank you.
Okay, thank you. And thank you to the EGEC for considering EVER for this prestigious award. Ladies and gentlemen, in the early days, we met a lot of resistance to the Everloop concept. And the same 3 objections came up time and time again. Firstly, we were told closed loop has been tried before and that it doesn't work. We explained that we overcame the relative inefficiencies of conduction-based geothermal by burying massive heat exchangers in the ground with more than 50 kilometers of horizontal pipe. But even if people were satisfied with this answer, they said the drilling would be too expensive. And 5 years ago, that would have been true. But with EVER's technology and advances made in the North American oil and gas industry, horizontal wells can now be drilled and completed within days. Which brought us to the third and most important question. Where have you built an Everloop? So last year, we constructed a full-scale prototype in Canada, and the results have exceeded all our expectations. The system has been up and running since December the 4th. The thermodynamic model and the performance data has been independently verified by TNO. Thermal output is within 1 to 2% of our initial predictions, and the system runs solely on thermosiphon with no pump load. Using the thermosiphon, we were also able to run the system as a constant base load heat source or by following fluctuations in demand over a 24-hour period. In conclusion, it is the world's first renewable energy source that is scalable, clean, and either baseload or dispatchable. We now have a pipeline of more than 50 commercial projects around the world, and the first of these will be drilled early next year. Thank you.
Yeah, thank you so much, Robert. Well, I'm going to pass the floor to Francis from Vulcan Energy Resources in order to give a few words about his of the innovation of lithium production from geothermal resources.
Thank you, Miklos. Can you hear me okay?
Yes.
Excellent. Well, thank you very much, and thank you to EGC for having Vulcan here today and giving us the opportunity to present. So my name is Francis Verdeen. I'm the founder and CEO of Vulcan Energy Resources. At Vulcan, we've come up with an innovative process to produce battery quality lithium hydroxide for use in electric vehicles from geothermal brines with a net zero carbon footprint. We call this our zero carbon lithium process. At Vulcan, we combine our different backgrounds in the lithium and geothermal industries, put these experiences together, and we've created something truly groundbreaking for these industries. And that is the world's first zero carbon lithium product. Why is this needed? Well, we are in the early but rapidly accelerating stages of transitioning to electric vehicles across the world. This will take a lot of carbon to do because batteries are very carbon intensive to make. And one of the items that goes into batteries is lithium. Geothermal brines can be rich in lithium. The carbon footprints that is required just for the lithium to transition to electric vehicles for passenger EVs in Europe is we've calculated as 230 million tons using current hard rock sources of lithium. That's equivalent to the annual CO2 emissions of Spain. Globally, this would be well over 1 billion tons. So this is a lot of CO2 that's at stake, and we want to do this transition properly. We want to get this right. So how does it work? Well, we use binary cycle ORC type plants of the type used already today in France and Germany, bolted together with a particular type of direct lithium extraction to take the lithium out of the brine. We then use a series of fairly industry standard steps to precipitate the lithium hydroxide. The brine goes back in the ground. It's all a closed loop system, so no gases escape. And the whole process is run by the heat and power from the geothermal plant. Actually, we produce an excess of energy which we can sell into the grid. Using this process to supply battery raw materials into Europe will be a game changer, both for the lithium and the geothermal industries. It will make geothermal projects much more attractive financially when there's lithium present in the brine and where flow rates are sufficient to support such an operation. And it will enable geothermal to become a much more significant part of the renewable energy mix. So very much in keeping with the hashtag geothermal decade. We are aiming for production in 2023. We will have our pilot plant operational by the end of this year. We've already completed a scoping study, which is positive. We're accelerating very, very quickly. And we're looking to service the very rapidly growing lithium hydroxide markets in Europe with our zero carbon lithium products produced from our geothermal brine projects in the upper Rhine Valley of Germany bordering France. Thank you very much.
Okay, thank you. Now I'm going to pass the floor to Anne in order to present the innovation of ZE Bayern.
Yeah, hello everybody. Thank you very much, Miklos, for the introduction, and thank you for the nomination. I want to introduce our innovation. It's a test rig for thermal response test devices, which was developed at ZE Bayern. It's the so-called emulated borehole heat exchanger. This test rig was developed and built as part of our joint project QEWS2. The project was financed by the German Federal Ministry for Economic Affairs and Energy and supported by the project management Jülich. Together with our joint partners, the Hochschule Biberach, the Karlsruhe Institute of Technology, the European Institute for Energy Research, Solites, and the companies Enoware and Burkhardt, we research on quality assurance for borehole heat exchangers. So now we are in the field of shallow geothermal energy. One result of this project was the development of the emulated borehole heat exchanger. This test rig can be used to check the functionality and testing procedure of classic fluid-based TRT devices. A thermal response test is usually carried out on a test borehole for a borehole heat exchanger field in order to determine the thermal properties of the underground, which are then used to design the whole borehole heat exchanger system. So the importance of the high accuracy of the test results is clear, as these are the requirements for a good efficiency of the borehole heat exchanger system. The TRT devices used for this purpose are usually self-built devices and have so far not been tested as a whole. In principle, this would be possible on a very well-known borehole heat exchanger, but the disadvantage here is that it is necessary to wait very, very long between the thermal response tests on such a, let's call it, calibration borehole heat exchanger, and that the boundary conditions are not identical. Therefore, we decided to build an emulated borehole heat exchanger to which the TRT devices can be connected like to a real borehole heat exchanger. And at this test rig, the TRT devices can be tested under reproducible boundary conditions. The special feature of our test rig is that it works according to the hardware in the loop principle and can react directly to the input parameters generated by the TRT device. With our emulated borehole heat exchanger, we can simulate different underground properties and borehole heat exchanger length. And we think that our test rig can help to increase the efficiency of shallow geothermal systems and thereby make an important contribution not only to the geothermal industry, but also to the reduction of emissions. Thank you.
Thank you, Anne, for your presentation. And now I must admit that as chairman of the jury, we had a great difficulty among us to first shortlist the candidates among the 9, because we have got very good candidates, very good innovations, and we see that the geothermal industry and the geothermal science and technology is innovating constantly every year, and more the projects which are submitted to this award, and not only they are much more interesting, and then it was really a challenge for us that all these innovations which are contributing in a way of mitigating climate change are so good and motivating, and I congratulate all the candidates who submitted their projects and all the shortlisted candidates, and I encourage everybody to continue innovating, because the actual conditions of our climate change and also our living and it motivates us to change our way of life and produce heat sustainably from the earth. Now I would like to pass the word to Sandra, who will announce the winner of this year. We don't hear you, Sandra.
Just a second, technical mistake. Okay, thanks, Miklas. Now we will start with the announcement. It has been a really hard decision this year. 2 companies were really close to each other. Therefore, the jury decided that this year is not a normal year, because this year we will have 2 winners for the European Geothermal Innovation Award. My congrats go to all finalists, but especially to the 2 winners. And the 2 winners of this award, which is now produced 2 times, are Carpfix Iceland, represented by Edda Aradotir, and Erfurt, Germany, represented by Robert Winslow. You both join me on the camera so that we can give the floor to the winners for some words. Let's start, ladies first, with Edda.
Thank you, Sandra. We are extremely honored to receive this award and the recognition it entails. We are grateful for the EGC for establishing the award, and also find ways to carry out the ceremony during these strange times that we are experiencing. Of course, we'd like to congratulate our fellow nominees as well, and our fellow winner. I think the 5 shortlisted projects show how diverse the field of innovation within the European geothermal community is, and also it's of great importance to highlight all the top-level research and innovation that is ongoing in Europe. Because of the continuous improvements that we are making through this innovation, we will become closer to achieving our climate goals, which is of course what all of us are doing as we are working within the renewable energy sector. So thank you from all of us at Carpfix. It's a great honor.
Thanks, Edda. Now, Robert, it's your turn. Welcome on stage.
Thank you. And thank you very much to everybody who voted for EVA. It's, as I mentioned at the beginning, it was prestigious to have even been nominated, and to win the award obviously is even better. We have a lot of people to thank for this and the progress that we've been made to date. Obviously, all of my colleagues at EVA and the many different partners that we have around the world. We were actually encouraged to apply for the award by Dr. Kreuter, so I'd also like to thank him and for the support that he and his staff have given us in the tremendous progress that we've already made in Germany. But as I mentioned, we have a whole series of projects now in the pipeline around the world. We think the first of those maybe in Germany. It's a bit of a race to see which goes first. But we're very excited about the future. We're very excited about working in partnership with the geothermal industry as a whole and helping to begin to change the world and to reverse climate change. So thank you again.
Thanks, Robert.
Congratulations.
So, all finalists will get a certificate, and of course, the winners will get also the award. Now you just can see it, but in some days it will be at your desk or somewhere else. And to make the moment last, we would like to take a picture. Therefore, Edda, could you just join on the camera again? And now the picture will be a screenshot. So other times today. And now I would like to pass the word over to Miklos.
Yes, well, thank you for this participating to this ceremony. In order to, as Sandra said, to have the moment continue, we do have a couple of minutes in order to address questions which come from the audience who are participating. Actually, I see there are 68 participants connected to this broadcast. So we are welcoming questions. Just raise your hand or type in your question in order to be able to give the floor to the nominees and to the winners to answer your questions. Well, questions can come also from the other panelists who are registered. So not only from the audience.
Miklos, we have a first question. I see in the list. It's a question to Francis for the Vulcan energy project.
Yes.
The question is which sites are selected by Vulcan Energy for lithium production in France and Germany?
Hello. Yeah, so we have an agreement with Pfalzwerke Geofuture to collaborate to construct a pilot plant for lithium extraction at their plant at Insheim. So that's where we see first production happening, and not just pilots, so first commercial production all going well. We also have a series of projects throughout the Upper Rhine Valley. In our scoping study, we focused on our Ortenau license, which is to the south of the Upper Rhine Valley. So that's where we see our own first projects developing, and we have 5 other licenses that we will be building out from there in various locations across the Upper Rhine Valley. So far just on the German side, but obviously we have the same conditions on the French side as well, so we'd be open to that in the future.
I also have a question connected to your project. How much lithium do you expect to produce a year, which will be eligible for car batteries, let's say, from a geothermal plant?
So we're listed on the Australian Stock Exchange, and at the moment I'm not allowed to release that information because of stock exchange regulations. But I mean, I can tell you that Europe's demands for lithium hydroxide within the next 8 years is set to be over 400,000 tons of lithium hydroxide. That, for context, is greater than the entire global demand today in the space of just 8 years. Now, we have defined a resource already of 14 million tons lithium carbonate equivalent in the ground. So we already have more than enough, certainly in the ground, to satisfy a substantial chunk of that demand. And we believe we will achieve very significant production rates when we get up and running, but unfortunately I can't put an exact number on it just now.
Okay, thank you. Because probably you know that France has released a plan of producing 1 million electric vehicles from 5 years from now. So I mean, I think all the car industry is down and everybody is moving to electricity. So your innovation will definitely contribute to the European lithium production and release the burden of importing lithium from other resources. Okay,
Miklos,
let's go
we
to
have
the
another
next
question. So it's somebody, Ingrid Paulatelo has raised her hand, so we will unmute you and you will be able to speak and to ask orally your question. Ingrid, the floor is yours.
Perfect. Thank you so much. Good morning. I would like to understand the size of all your companies. I would like to understand how many people work in the different companies that were nominated, and understand what is the roles of the people there, how many geologists you have, because geothermal is being this transition for many geologists from the oil and gas industry, and I want to understand if it's really a market there. Thank you.
Yeah, well, let's start then with giving the floor to each representative of each company to, let's say, to Joel, to see Baker oil field supply, how many people you have. Just give a short, let's say, overview of the staff and possibilities and potential. I think this is the question: what is the perspective of geothermal in terms of for geoscientists? Are you still there, Joel?
Yes, of course.
Yeah.
We are our company has about 70 people in the registered full-time service. So we are just growing in the geothermal industry and are heading up to even more.
Okay. So are you employing geoscientists in your company, or you are just technology providers?
Yes, we are just technology providers, so no geoscientists in-house.
Okay, thank you. Now let's ask Eda Aradottir in the CARFIX project. All this project, I think, is not only one company who develops that, it's a consortium. And this consortium, how many scientists and geoscientists work?
Yes, as you say, Miklos, the development of CARFIX was carried out through a consortium consisting of very active collaboration between the industry, the geothermal industry in Iceland, and academia, both here in Iceland, on mainland Europe, and in North America. I think over the past 12 years or so, we've had a tight group of about perhaps 20 people, mainly researchers, and then predominantly geologists, but also engineers that have mainly contributed to developing the technology. We've also put a lot of effort in developing and training next generation scientists and engineers. So we have, I think, close to 15 PhD students, which have finished their dissertation by researching and participating in the work carried out within CARFIX. Last year, a part of this research consortium, those of us that have been with Reykjavik Energy throughout the development of the process, we were moved into a new subsidiary of Reykjavik Energy. There are just 5 of us there currently, mainly scientists, and of course we hope that by taking the method beyond Iceland and also beyond geothermal, we will grow. But at the same time, we are aware that we will have to continue further innovation and development of the technology so that we are able to have the largest impact when it comes to reducing CO2 emissions.
Thank you. Well, now, Robert, your projects, I understand your projects are integrating a lot of geoscience, drilling, completion, everything. So how many jobs you generate while building a project, and how many jobs you will maintain while operating such a project for a geoscientist? Your view.
Yeah, thank you for the questions. We have 20 full-time staff in the company. That has grown with part-time and contractors about 35, and at least 20% of those people are geoscientists. So principally geologists, but we also have one geophysicist as well. We have GIS and mapping experts, and we expect that to continue, because what we're trying to do with the system is to turn geothermal into a repeatable manufacturing operation. But wherever we go in the world, even though we want to turn it into a manufacturing operation, the thing that is always different is what's happening below ground. So to be confident about drilling these systems, we at least need to have a good understanding of the subsurface. So having good well control, good geological data, good seismic data is extremely important. So we expect the number of geoscientists employed either directly or indirectly through the projects to increase dramatically. When we drilled the pilot project in Canada, we had one full-time geologist. We had obviously well site people while we were drilling it. We employed geophysicists to do the geophysical interpretation of the things, so that we could actually drill through what was a 15-meter thick sandstone, and to make sure that we stayed within that. So on the operation of the project itself, I would say there were around 10 geoscientists who were employed in the project. What we hope to do is to have literally hundreds, if not thousands, of projects in the ground within the next 10 years. So yes, geoscience is absolutely a core part of what we're doing, and a core part of our success going forward.
Yeah, thank you, Robert. Now let's ask Francis what the Vulcan Energy Resources projects will bring in terms of job and employment for geothermal development at large.
Yeah, sure. So it's a bit of a moving target for us at the moment. Obviously, we're in a very rapid growth phase. I'd say there's probably around 20 people working for the company at the moment. But a lot of those are currently contractors, not full-time employees. But the intention is that as we grow, we will retain more and more full-time. And the vast majority of those, I'd say 80%, are geoscientists of some kind. And we, as we build out, I mean, I'd echo Robert's comments a little bit. I mean, we do intend to replicate our process as well. After we build our first lithium plus geothermal plants, we intend to build many, many more, both in the Upper Rhine Valley and beyond. And in the scoping study, the full-size stage 2 lithium plants that we were looking at building employed roughly 80 personnel now. Obviously, there's some of those are more in an operational capacity, but certainly there will be a need as each of these projects is developed for geoscientists, and there will be a considerable need for them. So it's hard to put an exact figure on it, but it will be considerable.
Yeah. Thank you very much, Francis. Now let's ask Hanne for the shallow geothermal type of projects. How many employment do you have in your company, and then how much would your innovation probably generate, or your stream of business generate?
Yeah, good question, because we are a research institute. So at the whole research institute, we are around 180 people, but in our group, we are around 6 people, which are focusing mainly on shallow geothermal research. So we are mainly mechanical engineers, and we hope that with our research results, yeah, we can support the growth of the geothermal industry, and especially the shallow geothermal industry.
Okay, well, thank you. Well, we can see now that, well, just to complete all the answers and make a summary of the answers of all shortlist, all candidates, let's say geothermal has a great future. Whatever it is, we go from deep geothermal to shallow geothermal, and everywhere when we speak of geothermal, we will need to have geoscientists. And in complex projects as the Everloop, you will need geoscientists dealing with geomodels, geosteering, then in shallow geothermal projects, we will have also more geoscientists dealing with the geothermal, with the shallow geothermal loop. So I would say, and going to the exploitation of minerals, there we need geoscientists dealing with geochemistry, obviously, and not only that, because these are projects which are integrated in other projects. So geothermal in the future, we think we will pick up, and more geoscientists will be able to come to the geothermal industry when geothermal will become a real industry and will be at the size and of the ambitions as we already have in other mining industry like oil and gas or ore minerals or coal mining. So I encourage strongly all those who are looking for working in an interesting field to go to geothermal, because this is the place where you can have the most challenging projects ever. Okay, do we have other questions, Philip?
No, we have not received more questions. Nobody also is raising the... okay, one more question just arrived now. Okay, this... Yeah, it's a bit complicated. How and where? Yeah, how and where to work on geothermal. But first, we could say that we look at many in Europe from our side, no? But it was more a complementary question. So indeed, there's no really more question. Miklos?
Okay. Well, then I think we can go to adjourning this webcast, and thanking to all participants, thanking to the winners, and thanking to everybody who contributes to innovation in geothermal, and wish you good luck and success, and take care in the future. And we will see each other in 2021 in Offenburg. And then maybe Sandra could conclude, then it's a lady who will speak last.
Yeah, I'm pleased to welcome you into 2021, and in the evening we will all have a glass of wine and think about this year 2020. So
Okay.
For me, thanks a lot, and for the next months a lot of hope, and we will come back to you.
Okay, thank you and goodbye.
Bye.
Thank you. Bye.